So for this particular question, we know that this question is on energy. Alright, so last I was always telling you, the first rule that you need to understand is that energy cannot be created or destroyed. So what it means is that if you have 100 units of energy, you must have 100 units of energy, whatever happens. So what it means is that when you take a look at the next question, so your gravitational potential energy is affected mainly by your height. So they ask from point A to point B, which is actually essentially from here to here. So you think about it, at this juncture here, okay, the ball is going down, means that your GPE will be going down. So if it's going down, another energy must be going up, and that is your KE. Because what goes down, the other must goes up in order to balance up, to become the same amount of energy. So therefore, your gravitational potential energy, this will be decreasing and this will be increasing. Now, next part, fill in the boxes according to show the energy conversions. So if you take a look at it, okay, at point B, which is over here, we know that the ball is falling. So when it's falling from a height, there is GPE because it's still above ground. At the same time, there is also movement. So we know that, okay, there is kinetic energy and there's gravitational potential energy. Now at C, when it hits the ground, okay, there are mainly a few energy when it hits the ground. Firstly, there is actually sound energy, okay, because it will land with probably like a tug. And then after that, the next thing would be your heat energy. Okay, so if there's heat energy, then there will be another one that you can actually write. Okay? So the other energy that you can write will be kinetic energy. Now why is it kinetic energy? That's because at this juncture over here, the ball didn't stop in motion. It is still moving. It is still moving. Okay? Now give a reason in terms of energy conversion why the basketball bounced back from the ground at a lower height. Okay? So take a look at here. Usually you would use whatever the energy conversion flow to help you answer. So over here, right, at C, it's saying that after C, it went back up to a lower height compared to where it originally came from. So originally we say that we can say that the highest height is over at this juncture. How come it did not bounce back towards the same height? Okay, instead it actually reached this height. So your answer is actually, the answer does not lie in gravity. The answer lies in this part over here, which is your sound energy and your heat energy. Not your kinetic energy, because your kinetic energy is what enables it to go back up. Okay? So you have to say that some of the what energy? So you look at here. Kinetic energy, very good. Is converted to sound and heat energy. Now some of you may go, why isn't this answer here gravitational potential energy? Right? Because you see there's gravitational potential energy. In fact, gravitational potential energy is right next to your sound energy. How come I don't say some of the gravitational potential energy is converted to sound and heat energy? Well, in all honesty, in exam, we usually give this as a mark. However, that is not the most correct answer because when you think about it, especially in terms of heat, okay, where do you get this heat from is that it comes from the frictional force that is generated between the ball, okay, and the floor when the ball hits the ground. So in order to actually have that friction, there must be movement. And when there's movement, you need kinetic energy. So it is your kinetic energy that actually becomes your heat energy. Okay? Just to be clear. In the next throw, Ravi threw the ball with a greater amount of strength and in the same direction. He observed the ball reach the net in a shorter period of time, explains his in terms of energy conversion. So once again, like I say already, you have to use this to help you. Right? So basically, when you take a look at here, he threw the ball, okay, with greater amount of strength. So greater amount of strength in this case means that he needs to use more chemical potential energy. Right? So the chemical potential energy would then convert to more kinetic energy in his arm, which is then converted to more kinetic energy of the ball, enabling it to travel faster. Okay, now when you want to answer this kind of question, the key idea is two things. You must show where does this energy conversion take place. Where? And that is the main problem in most, if not all, of your answers. So I'm going to actually write it out and I'm going to color code for you. So I will first say that more CPE, chemical potential energy in his or in Ravi so this is my location in Ravi is converted to more kinetic energy in Ravi's arm, which is converted or transferred to more kinetic energy of the moving ball. Okay? So what are the key things? So firstly, I'm stating what type of energy. Okay? So these are my energy. Next, I am stating where is this energy. Okay, moving ball. Okay. Can you add one more thing here? Moving arm. So usually, right, for kinetic energy, I like to pair it with a verb. So for example, when I'm talking about water dripping, I will say more kinetic energy of the dripping water. Understand? So this will be very clear for the examiner that this kinetic energy happens to a specific movement. Whether is it falling water, a falling ball, a ball that is being thrown. And then after that, I must have all my comparison words. All the more needs to be there. Okay? So more chemical potential energy in Ravi is converted to more kinetic energy in Ravi's moving arm, which is converted to more kinetic energy of the moving ball. This enables it to move at a faster speed. But you do not need to put the last part there because, yes, you do. Because they ask you why take a shorter time, right? So enabling it to reach the net at shorter time. Enable to move faster, move faster. Okay, the key idea is move faster, not reach the net in a shorter period of time. Why? Because if you put shorter period of time, you are actually copying. You're just lifting from the question. But when you say it's moving faster, you are answering why take a shorter amount of time. You see the difference over here? Okay? So we have to be very clear about what we are talking about. Yes, you have to write chemical potential energy. You cannot use short form or acronyms during exams. Next. This question. Tina conducted an experiment as below. She placed a wooden block on a sheet made of X. She then pushed the block with a force F. The block moved forward and traveled for a distance d cm as shown below. When you see an experiment, no need to see already. The first thing that you need to do is to actually annotate for your change and measured variable. So, look at here. I see the keyword force. Okay, I see the keyword force. This tells me that the topic is force. Why am I telling you this? Because in an actual exam, you will not be told what is the topic. You have to read the question and analyze what is the topic. So now that I have keywords that tell me that this is a force, okay, I know that the topic is force. I know the common concept tested will be things like lubricant, frictional force, okay, things like this, correct? Elastic spring force. So these are the various concepts that can be tested. And then it helps me narrow down what exactly is this question asking and which concept are they testing. Then the next thing I do is, what is the change variable? So your material over here is the change variable. I have to annotate here. And this is your measured variable. Okay? What force was acting on the block as it moved? Take note. Okay? 99.999999% unless there is a special circumstance, everything on Earth, okay, definitely will have gravity. And this is a trick question because you realize it was was and were. Okay, so they are trying to hint you that there is two forces. Not all the time, but we know that gravity is one of them. And the second force that was acting on it is actually frictional force. These two. Okay, so you can either use frictional force or you can write friction. Gravity or gravitational force, both accepted. Next, suggest what Tina could do to obtain more reliable results. Now, be very careful. There are three types of questions that students always mix up. Reliability, accuracy, as well as fair test. Okay, so in reliability, there are two standard answers. One is to repeat the experiment at least 3 times and take the average. Take the average is a must. Don't have that, minus half a mark. The other alternative answer for reliability is actually increase sample size. So I'm going to write it down. There are two methods. Firstly is repeat. The second one is sample size. Either one of it, you pick. So sample size is, instead of using 1x, 1y, 1z, okay, I will have like 10x, 10y, 10z happening all at the same time. That means I place 10 bots of x, 10 bots of y, and 10z, and then I let it occur at the same time. You understand what I'm saying? That is what is meant by sample size. Repeat means I do the whole experiment one at a time and I do it 10 times. Okay, so for example, I may do this, okay, after I do finish it, I do again with the same board, again and again and again and again and again for 10 times. Okay, sample size means I have 10 boards, same time I do, okay, for X. So the most common one would be repeat the experiment at least 3 times and take the average of the results. And once again, I've explained it many times, it is not just 3 times. Most, I don't know why, people will say it's 3 times. No, the more, the merrier. The more times you repeat, the more reliable it becomes. Okay? Next. Alright? In an amusement park, people move down a slope in a special car shown below. Okay? Usually, I mean, if you actually read enough questions, there are certain tale-telling signs on what topic this question should be. So even before going on, I did see things like wheel, you know, and then I ask myself, which part do I usually see wheel? You know, it's probably got to do with friction. The topic will be on forces, the concept tested will be on friction. Simply because, you know, they're probably going to test you about the wear and tear of the wheel and everything else, somewhere along those lines. This is just my guess. I only read the question up to here. Okay? But this is what you need to do. Form certain ideas, but you shouldn't jump to conclusion either. Okay? People can pull the handbar at the back to slow down or stop the special car. When the handlebar is pulled back, the brake pad moves and touch part A. Brake pad. So based on general knowledge, I should know that the brake pad helps to slow down or stop a moving object. Okay? Stopping or slowing the wheel. Oh, there you go. So you see, when it's put back, if this part here is in contact. You see, at first it is not in contact, there is a gap. And now, it is actually touching. So this tells me straight away that there is actually friction, right, between this part here. And roughly I could get an idea of what they're going to ask me already. Okay? So they're not asking me about wear and tear of the wheels, the tires, but now they're asking me about this part. So that's why I say don't jump to conclusion. But it's good to have a rough idea. Based on Tina's experiment, which material X, Y, or Z is most suitable to make the brake pads, okay, such that the special car can stop in the shortest time when the same amount, okay, of force is applied to pull the handlebar. Explain your answer. So basically, I have 3 things over here to choose from, right? So remember, you're given a choice. Choice stands for C. C, then remember C-E-R-U. There is a usage here. The usage is where? Okay, stop in the shortest time. You want to stop something. So you're going to use C-E-R-U to answer this question. I'm going to demonstrate to you. So C stands for choice. You're given a choice. Now, whenever you're given a table, right, you must use data from the table as evidence. That is my E. So looking at it, okay, my change variable is X, Y, or Z. Okay, I would choose Y. Why then? Because Y has the shortest distance D. This tells me that the friction between material Y and the floor, or rather and the wooden block, is the greatest. So how do I write this? Okay. First one. C. Material Y. E. Yes, you can write this during exam. You don't have to, but you should, because it forces you to remember. Remember, evidence is what you see from the table. I don't want you all to add any more things. Just what you see from the table, which is actually your change variable and your measured variable. So you have to say that, okay, with material Y, the wooden block moved the shortest. That's it. You are quoting evidence. You are quoting evidence from the table. That's it. I don't want you all to say things like, wow, material Y has the greatest friction. Like that, you lose half a mark. So the has the greatest friction is what you concluded. But where is the evidence to support your conclusion? It's as if saying that, okay, this is a chair. Then I'll go, why do you say it's a chair? Then you have to give me evidence. Okay? So then the next part, the R, you would then talk about what can you conclude, or my favorite word, what does the evidence suggest? This suggests, and this suggests, right, is a very nice term that is used in the writing of proper scientific paper. Yes, when you go to university, because you will do experiment and then based on the results, you will say this suggests that material Y has the greatest friction between itself and the wooden block. Right? So this is the R part. Now we go on to finally the U part, the usage part. CERU. I have repeated myself many times and I was very explicit. So U in this case is usage. Hence, by using Y as the brake pad, the car will stop. Okay, hold on. The friction between the pads and the wheel, right? Check. Wheel and part A. So you see, I'm also checking, even as a teacher, I'm checking to make sure. Please copy exactly. If they say part A means part A, don't tell me wheel. You must copy exactly what the question says is the greatest. Full stop. Okay, so the last part, the U, is important. This part over here tells me that tells me about what I found out based on the result. This part over here tells me about, okay, when I use it as the brake pad, what will happen? So I'm applying it. Do you see the difference? Okay? The last question. At a game store, John had to burst a black balloon with a dart in order to win the prize. He aimed the black balloon and threw the dart in a straight line. However, the dart hit and burst a white balloon below it instead. So if you take a look at it, you will realize that the trajectory of it went down. It goes towards. And that's why your white balloon was eliminated instead of the black balloon. Okay? Explain in terms of forces. So the fact is, when they tell you forces already, you will think of things like gravity, also known as your gravitational potential energy. Okay? Okay, wait. Sorry. In forces you can say is gravitational force, elastic spring force, friction. Okay? So, please be careful. Just make sure that you don't accidentally put gravitational potential energy or gravitational potential force. Okay? Actually, that was what I was trying to tell you. Now, why the duck hit the white balloon instead, even though there was no wind? So, think about it in terms of it as in like, what is acting on it? The gravitational force. Your gravity. So, you must say that gravitational force was pulling the duct down. Okay, so this caused the duct to move lower instead of going in a straight line. Now, in this case, you don't really need to talk about air resistance because in this case, they put here no wind. Alright, no wind. So the main idea of forces in this case will be your gravity, which is acting on your duct, pulling it downwards. Okay, downwards. Okay, next. Without moving closer and making any changes to the balloons and ducts, suggest how John could burst the black balloon. So, cannot move closer, okay, but need to burst the black balloon. So, he would need to aim, okay, or position his duct higher so that when it goes up, it comes down, okay? So, John will need to aim higher and throw the duct higher. Okay? So because by aiming higher, he throws it higher, okay? He accounts for the gravity that is acting for it. Acting on the duct. Now, the balloons are fully inflated at the game stall. John observed that the balloons are bursting on their own and more easily on a hot day. So when you take a look at this question, you must understand some of the key ideas. Now, fully inflated means that it is filled with air. So when it's filled with air, that means it's full already, at the maximum already, right? Because the word fully inflated. Then he said burst on their own without anybody doing anything. And then more easily on a hotter day. So hotter day means increase in temperature. So ask yourself this question. In order for the balloon to burst, either somebody pokes it or it will be over-inflated. So in this case, because they said nobody was there to touch it or do anything, the balloon must have over-inflated. And the only way it can over-inflated, and it's got to do with heat, this tells you that it's got to do with expansion. So what is expanding? The air inside the balloon is expanding. So when the air expands, it actually occupies more space, causing your balloon to overstretch. So you need to understand one thing. The balloon is already stretched. If you say causing the balloon to stretch, you are not telling the examiner anything. Because whether it expands or it doesn't expand, the balloon is still stretched. Okay? So 2 marks means that you must explain. So you have to say that on a hotter day, okay, the air in the balloon gained more heat or gained heat faster from the surrounding. Hence, the air in the balloon expanded more hence the air in the balloon expanded more and occupied more space in the balloon. The balloon overstretched and burst. Okay? So once again, when it's got to do with a transfer of heat, you must, it's an absolute must to say from where to where. It is not good enough to just say, oh, gain heat. But gain heat from where? And don't forget, is gain more heat or gain heat faster? Because they say on a hotter day. So which means that actually on a hot day, the air in the balloon is still gaining heat, right? But on a hotter day, it gains even more heat, expands even more, so much so until the balloon became overstretched and burst.